congruent between triangles, you could have different lengths for the third. Okay? You can get different lengths for the third. The reason that you can get different lengths for the third is because the angle between the two sets of sides, remember that's called an included angle. Included angles are angles between sets of congruent sides. The angle in between those two sides isn't congruent. Right? One's a different measure than the other. In this one here, I can say that maybe this one is 92 degrees, and this one might be 27 degrees. So if I call this triangle ABC, and this one X, Y, Z, what happens here, you'll notice you've got two sets of sides that are congruent, which is completely possible. It can happen. It does not necessarily mean that you're going to wind up with a third set of sides, or some other angle that's congruent between or with them for a side angle side. But if you look at that, which of those two angles is larger, 92 or 27? 92. Real tough question. So thinking in terms of what we've done the past couple of days, which side length opposite, either BC or YZ, do you think is going to be larger? Right, and that's quite literally all this is. It goes back to the idea, remember how we did the hand thing? When you did the hand thing, the more you opened up your hands, the larger the angle was, the longer the side length between your fingertips winds up becoming. That's really all this is. So no matter what, if you've got two sets of sides that are congruent, whichever angle is larger has the longer side length. It's something that we call the hinge theorem. This is called the hinge theorem. And it's basically this. If two sets of congruent sides you have two sets of congruent sides for two triangles. The third side will be longer opposite the larger included angle. Okay. If two sets of congruent sides are for two triangles, the third side will be longer opposite the larger angle. Again, the more you open up the angle, the longer the side. That's really all this is. Okay? It's called the hinge theorem. And it's basically, it's designed off of the door, because doors have hinges. I know, it's tough. So, do you agree that this door is the same door by Mr. Lofthouse's room? No? What? It's hard to believe, but it's the same style and dimensions. I know. This is a difficult thing to grasp. So if my door is only opened up this much, and his door is opened up all the way, who has the bigger opening to walk through? The other dudes. The other dudes. Because the other dudes has a larger angle open. It's kind of like, I'm sure most of you guys at some point in your time have walked through a gate in a fence.
Not jump fences.
At some point in time in your life, you might have opened up a door. I know, they're weird. What is this? If you're a mine, you're stuck inside one like forever. You don't know what's going on. So, this is, like I said, this is a real difficult concept. So, that's where we're at. Congratulations.
No, I don't think.
I know it's the same picture. It was in the paper though. Congrats. What seems so cool about it? You want to go get it? It's so far away. You're so far away. You're like the only kid that I've had so far. That should feel like cool. It's cooking. If you use the hinge theorem to open the door all the way, you'll have more of an opening to get in and out of. Well, now you're screwed. You can't come back. Like I said, there's a lot of words to this stuff for basically the larger the angle, the longer the side. So, here's an example of what it looks like. Told you to leave the door open. The hinge is broke. I see they did that. We should ask. We should make an example.
No. Wait. You don't know that song. You should next one. You know that song?
Which one has got a longer side across? Which angle's bigger? You may answer. That's not mine. That's not mine. So, in this example here, which one is going to be the longer side length opposite the given angle?
Oh, wait. Wait.
Because last time I checked, 7 is the same thing as 7, and 4 is the same thing as 4. I'm hoping that I'm not like going off on a complete crazy land on this one. And 125 is larger than, it's larger than 78. You agree? Okay. So now with this giant leap of faith here, do we all agree that has to be the longer of the two sides?
Yeah.
So if I asked you to write out an inequality for the two side lengths, I would say that ln is greater than QO. But yeah, this is all pretty easy. Now, just like most theorems and definitions and things that we deal with in here, every one of them can be said in reverse. What I mean by that is that we've used what's called a converse of a statement. A triangle is acute if and only if, or if all the angles are acute. If all the angles are acute, then the triangle is acute, so on and so on. So what we can do is say this in reverse. If two sides of a triangle, or I should say two sets of sides, Yeah, if two sets of sides are congruent, the included angle will be larger opposite the longer third side. It's saying the exact same thing in reverse. The larger angle has the longest side has the larger angle. That's really all this is getting at. And the reason why I wanted to make sure we wrote it out this direction as well is because this is the direction that most of the times that we do the algebra instead of the problems and showing how it works. So, really quick and painless example here, algebra. When we're dealing with inequalities, we're still going to be dealing with boundaries. We're going to be dealing with an upper boundary and a lower boundary for possible values. Okay? When we do that, remember we did this the other day where you add them together, you subtract them. That's how you got your side lengths. Well, sometimes we also deal with it in terms of diagrams to find possible values of x for the range. When we're talking about possible values, we're talking about upper and lower limits. What's the upper boundary? It's the lower boundary. This would be a really good example. Make sure you have drawn out, because this is what a lot of the problems look like that use what's called this hinge diff. I'll give you a second to draw that out and talk about it here. So in this one here, you guys all see that you have one set of congruent sides. RU and TU. You guys all see that? Okay. Is there a second set of congruent sides? Yeah. Where? Reflexive. Yeah, exactly. You get this reflexive side again. Remember, it's not that we're doing proofs or anything like that, but we still have the properties that show up. So you get the reflexive side there. So that means that you have the included angles. You have an included angle of 60, and you have an included angle of 5x minus 20. Which of those two angles has to be larger? The 60. Yeah, the 60 degree angle has to be larger than the other one because it's the side opposite it is larger. Since the 15 is larger than the 10, that makes the 60 the larger of the two angles. Okay? Which means, can the angle of 5x minus 20 be bigger than 60? No. So what happens is we use the inequality as the 60 is your upper limit. The other angle has to be smaller than it. You have an upper limit of 60 degrees. So 60 degrees has to be it has to be smaller than 60 degrees.
Is that like the
Kinda. What's that? Yeah, exactly. And when we're dealing with inequalities in algebra, the only time you have to worry about anything is if you ever multiply or divide by a negative. That's when the signs flip. But quite honestly, I don't think I remember seeing that very often in any geometry textbook. So you just solve this like you would anything else. So what's your first step? Add 20. Very good. Add 20.
Sorry, sir.
and you divide by 5, and you get 16, if I'm not mistaken. Which means that x would have to be smaller than 16. If it gets to be larger than 16, then all of a sudden it'll be bigger than 16, and then it won't work. Lower limit then. Well, what's the lower boundary of it? What does an angle always has to be greater than? 0. The lower limit for all these angles has to be 0. Okay? Because you can't have negative angles. Your lower limit will always be 0, so that means that your 0, your angle has to be greater than 0. See where I'm going with that? The upper limit is the other given angle. It's got to be smaller than the given angle, but it always has to be greater than 0. And this will work like that little trick like that every time. And this one is a really, really fast one to worry about. Add 20, divide by 5, and you get 4. Right. And just like we did the other day when we solved our inequalities, we always wrote them as a compound. We do the same thing. That means that x is greater than 4, but it is smaller than 16.
Okay, so that's easier.
You get the boundaries then. Any value of x that you choose that's bigger than 4, but yet smaller than 16, will work. That's what we're getting. Okay? That's what we're doing. It's not too terrible, is it? You guys do this one. Well, if you weren't talking and chit-chatting. You guys figure out the possible range of values in this one. Please, Andy, thank you. What? What's your upper boundary? 90. Yeah, you're right. We solve x you correct. The first thing you do, add 3x plus 18 has to be smaller than 90. Okay. What's your lower boundary that you have to set equal to?
0.
Not equal, but it has to be greater than 0. Now, watch what happens when you deal with 0 one. Well, the first one was easy. 3x plus 18 has to be smaller than 90. The other one is 3x plus 18 has to be greater than 0. Everybody's okay here? You get x has to be smaller than 24 when you did that?
Yeah.
I'm assuming?
Yeah.
Okay. On the other side, you have to pay attention to what happens with your negative. You subtract the 18 over, you get negative 18, which means x is greater than negative 6. Is it okay to have a value of x that's negative? Yes. Because if you pick any number bigger than negative 6, for example, negative 5, I take negative 5 and I substitute it into here. What's 3 times negative 5? Negative 15. What's negative 15 plus 18? 3. Is it a positive angle? Yeah. Remember, it's okay to have negative values. It's not that you're generating negative angles and or negative segments. So you can have values that are negative. It's one of those things that shows up pretty regularly. So your boundary that you would write out for this one then would be pretty simple. X is bigger than negative 6, but smaller than 24. What do you? Oh, when I picked a number bigger than negative 6. I just was showing that it works. If you use negative 4, negative 4 times 3 is negative 12. Negative 12 plus 18 would have been 6, and so on. So it's okay that you have a value of x that's negative, as long as that x value is bigger than negative 6. I was just showing that it's okay. All right? It could have been 0. Because 3 times 0 is 0. 0 plus 18 is 18. And it still works. All right. That's where we get it. Did you want to move that up some for you? Did you want me to just chop Chase in half so that we can see over his head? Yes. The answer is yes. Okay, not too bad. So problem-wise, if you have these, there's only, I think, like 9 or so. I want to say. Not too many. It's in the book again. First few are just writing out the inequalities. The next bunch are some algebra ones like we just did.
Put that thing in store. You can read my butt.
Yeah, I think the first five are just writing out inequalities, which side's bigger. The next 4 are what are the boundaries, what are your different set of values you can get for x. And then the last 3 are also some quick inequality ones if I look at the diagram. From what I remember from yesterday, I had heard about this while we were gone. I guess there's a whole bunch of problems with Chromebooks. What happened yesterday? Now, if you're still not able to log in or get into the Wi-Fi, there's an instruction sheet here telling you how to fix that. Also, make sure right now you pull it up and get a screenshot of it in case that happens again. Because if you have a screenshot on there, you should be okay. You'll still be able to open it up and go. All right? Sir?
May I please go fill this out?
Works for me? Want to get started? Not mistaken.